Hello everyone, here is Alex from Cloud by Example. Today I would like to tell you about how to authenticate in Cognito with Srp. In this video I will tell you what an Srp protocol is and how it works on a very high level, how Srp exactly works in Cognito, and how you can implement Srp using Cognito with a very simple example that is going to use a CDK application that you will be able to quickly deploy on your machine. So let's start with some basics. So how the authentication with a regular username and password works. This is relatively straightforward. We start with a registration. During this process, we send a username and a password to the server. The server then creates a random value called salt and with the password calculates a special value called hash, which then together with the salt and the username is stored in a database. Now, when we want to authenticate later, we again send the same username and the password to the server. Server retrieves previously stored hash and salt from a database, recalculates the hash using the password that we provided, and compares those two values. If those two values matches, then obviously we are authenticated, we provided the correct password. And as you can see in this picture, the actual password needs to travel from the client, so from the user, to the server over the wire. Yes, under normal circumstances, this password will travel over an encrypted channel, but still the password has to be sent to the server. This is how a regular username and password authentication works. Now, what is an SRP? It stands for Secure Remote Password. This is a special protocol. Basically a standard protocol that allows us to authenticate a user without actually sending the password over the wire. The only place where we really need to send the password is when we sign up at the beginning. So we provide a username and password, which we send to the server. The server then calculates a special value called verifier and uses the password that we send to calculate the special verifier. And it also creates a random salt and stores everything in a database. So the username, the verifier, and the salt. Now, when we later want to sign in, when we want to authenticate, the process looks as follows. We calculate a special random value called SRPA. This is, I'm not going to get into details how this value is exactly calculated. It doesn't really matter. It's a random value. And then we send this random value together with our username to the server. What the server does, it calculates yet another random value called SRPB from the username that we and the SRPA that we sent to it, and sends back to us this calculated random SRPB and the salt that it previously stored for our user. What then happens on the client side is the client calculates a session key using, among other parameters, the password itself. So the password doesn't leave the client, but the client only calculates the session key, and from the session key it derives a proof of that key. And then it sends the proof of that key to the server. So it doesn't send the actual key, just the proof of it. What the server now do is it calculates the same session key by itself, having the values that it has at hand, and calculates the proof of that key as well, and then compares the proof that was sent by the client. If those two values matches, then it sends this proof that it calculated to the client, and the client does exactly the same comparison. So it compares the proof of the key that got calculated by the server. When they match, it means that we got properly authenticated, and it means that now both the client and the server have a session key that they can use to encrypt the rest of the communication that will flow between the client and the server. And as you can see, in this whole process, the password never left the client. The keys, the session key that was calculated, also never left the client, and it also never left the server. Only the proof of the key was exchanged to make sure that both ends, both sides of the communication have the same key, so that they can later communicate and encrypt and decrypt the communication with that key. And this whole communication between the client and the server under normal circumstances will still be encrypted, yet on the higher level with SSL, obviously. Now, how do we use SRP with Cognito? The first idea that comes to mind is, okay, there is an SDK, so clearly there must be a support for it in the SDK. And yes, you can trigger the authentication flow and Cognito will respond with a challenge. The problem is that you cannot really do all the calculations within the SDK. SDK doesn't support it, basically. It only sends you the challenge, and the rest of the flow is entirely up to you how you do it. So the next thing that comes to mind is, okay, since this is a standard protocol defined in an RFC, then clearly there must be third-party libraries that are already supporting this specific protocol, right? And the problem is that SRP in Cognito is not a standard SRP. So yes, it's called Secure Remote Password, but it's not the RFC 5054 standard, which is the current one, so the so-called SRP 6A standard, is just a variation of this protocol implemented in Cognito, but it's not a standard one, it's not compatible. So if you try to use any of the existing libraries to calculate those values that are within the protocol, you will soon notice that this simply doesn't work. Okay, so how does SRP actually work in Cognito? It starts pretty much the same. So we send, upon sign up, we send the username and password, and the server, this is just my suspicion because I don't really know what happens on the server, but basically it has to store the username, the verifier, and the salt. Now, when we sign in, so during the authentication process, it starts very similar. So we generate a random SRPA value, and we send this SRPA together with our username to the server. Now, if you remember from how the regular SRP, so how the standard SRP works, it then responds with two values, SRPB and salt. Cognito, on the other hand, responds with three values and sends us an SRPB, salt, and a secret block. Now, those three values together with our password and other, let's say, Cognito related attributes are used to calculate the signature. And when we calculate the signature on our end, we send it back with the username, the secret block, and the signature back to Cognito. Cognito then compares the signature. Most likely it calculated exactly the same signature. It compares them. And if they are the same, then it returns us the OpenID Connect tokens. But as you can see, this is not how the standard protocol works. Okay, so now we know that we cannot really rely on the SDK. We cannot rely on third-party libraries because this is not the standard SRP. So what can we actually do? First option is if you are using an Amplify framework, then this framework already got you covered. So basically the whole SRP is included there. All you have to do is to configure the framework itself and basically trigger the authentication, and the framework will do the rest for you. So this is the simplest solution probably, but obviously it requires the use of the framework. Another option is there is an example in Java SDK. So if you are a Java developer, then it should be relatively straightforward how to do this, how to calculate those values. It's more or less a copy paste that you have to do from the Java SDK. And there are already a few ports available in the internet, at least 3 that I was able to find. One is for Python, one is for PHP, and one is for Ruby. I included links to all 3 of them in the description of this video. Okay, so let's try to use SRP and authenticate with this protocol. I will do this with the help of the Python implementation that I found online, and in the description of this video you will find a link to GitHub where there is a repository with all the steps necessary to reproduce this example. If you are using Visual Studio Code, there is also a .dev container directory there, so you will be able to start the entire container which has all the dependencies already installed and all the requirements are already met to be able to run it. So there's also a README file with all the descriptions, so you should be able to easily launch everything. Okay, so the first thing that we will do, we go to the CDK directory and we have to run npm install. Okay, now we have all of the dependencies, so we can run npm run build. Okay, now that we have the actual application built, we can simply deploy it. Now let's copy the client ID and the user ID from the outputs because we are going to need them later. And now we can start by creating a new user. For that, we have to replace the value with the client ID. As we can see, the user by default is unconfirmed, so we will have to confirm it. For that, we actually need the pool ID. And the empty response pretty much means that everything went fine. And I will use the Python implementation that I found online to do the actual authentication. And for it to work, we need obviously our username, the password, we need the pool ID, the client ID, and the region in which the pool was created. Now the pool ID and the client ID will also be used to calculate the final signature. So they are not just there to allow us the communication to Cognito, but they will be technically used to calculate the final value, the final signature. And here we go. We have the response from Cognito with access token, refresh token, and ID token, which means we got properly authenticated. Okay, and if you are following along, now we can destroy the pool. As you can see, this is relatively straightforward. If you are using one of the ports that are available on the internet, then the whole procedure is really simple. There's nothing special there. You just provide the username, password, user pool ID, client ID, and the region, and that's all you need to do. Everything else will be taken by the code. There are though a few things that you may want to keep in mind when it comes to authentication. One of them, probably not that relevant, is that you have only 30 seconds to provide the response to the challenge. Now, normally this is not really a big deal because you don't really do anything else from the moment you receive the actual challenge until you actually do the calculation and send it back. But if you were to do anything between those two steps, then you have to keep in mind that after 30 seconds, the challenge simply is gone. And even if you send the proper signature, you will still be greeted by a username, invalid username and password message. Another probably way more important detail is that Cognito will not tell you that you are trying to authenticate with a non-existing user. In case you generate an SRPA value and send it with a non-existing username, Cognito will still issue the challenge. Even if you calculate the signature correctly, the response will be an invalid username or password. Finally, you can enable SRP authentication on an already existing user pool client. So we can start our user pool with a regular, let's say that you started building your user pool with a regular username and password authentication. And you already have user in that pool, but you did not enable SRP at the beginning. Doesn't really matter. If you had regular username password authentication enabled before and your users have passwords, then you will be able to switch to SRP. Let's quickly check this. We can redeploy our application, but this time with username and password. Okay, now we can quickly create the user. We again need the client ID to do this. The user is obviously not confirmed. We need to confirm it first. Now we can try to actually authenticate with the username and password to see if everything works as expected. That we need to replace the client ID value. Everything works as expected, so we receive the tokens, access, refresh, and ID. That was relatively simple. Now let's update our user pool and switch it back to SRP. If we now try to again authenticate with a username and password, and we will get a notification that the username password authentication flow is not enabled for this client, right? We did it. We have the SRP enabled. So we can now try again the script to authenticate with SRP. We need to provide the client ID, the pool ID, and the region. And as you can see, everything works as expected. So we receive the access token, refresh token, and ID the token. And if you followed along, you can now destroy the whole stack. A quick summary. So SDKs don't provide full support for SRP. You will have to find a way to work around this, either if you are using the Amplify framework, or if you are using Java, then you have examples in the SDK, or there are ports, already existing ports in several languages. And if you don't find something in your language, then obviously you can still build it based on the existing examples that you can find in the internet. You have up to 30 seconds to calculate and send back the signature. That might not really be that big of a deal. You also have to remember that the SRPB and salt and the secret block will always be returned, even if you provide a non-existing username, and you will still have to calculate the signature, and you will then get an invalid username and password message in response. And if you already have a user pool client with a username and password authentication, then you can just switch it to or enable additionally SRP without any issues. And all the users will simply work out of the box. That's it for today. Thank you for watching this video. And if you like it, hit the subscribe button or like the video. Hope to see you in the next video.